Hello everyone. In this video we will be going through the 10 questions based on the remainder problems. These have been answered on my Quora, and there is a blog called as prepareyourmathblog.quora.com. You can visit there for more remainder problems. Let's go with the first question. What is the remainder obtained when 2 raised to 50 is divided by 7? First of all, we know that the multiple 7 is 2 cube is 8, and it is what is the difference between 8 and 7? It's 1. Therefore, the remainder when 8 is divided by 7 is 1. Now we need 2 raised to 50. Therefore, we by increasing 16 on the both the sides, rising to the 16 on the both the sides, that is 2 cube whole raised to 16 is equivalent to 1 raised to 16 mod of 7. Now 1 raised to 16 will be always 1. Therefore, we get it as 2 raised to 48 is congruent to 1 mod 7. Now 2 raised to 48, this is same I have written, and multiplying both sides by 2 square. Since we need 2 raised to 50, but we have 2 raised to 48. Multiplying both sides by 2 square, we get it as 2 raised to 50. That 2 square is 4. Therefore, 4 mod 7. 4 is less than 7, therefore it cannot be divided further. Therefore, the remainder is 4. Next question. What will be the remainder when 5m plus 1, 5m plus 3, 5m plus 4 is divided by 5? The solution goes like this. This term is perfectly divisible by 5 since it is a multiple of 5. 5m is perfectly divisible by 5. But when you add extra 1, it is not divisible. Therefore, the remainders are 1. Similarly with this one, 1, 3, 4. Now when we multiply these all three, the same follows on the right hand side. That is 1 into 3 into 4. Now 1 into 3 into 4 is 12. 12 is greater than 5. Therefore, it can be divided. And the remainder mod means it's need to find the remainder. That is 12 mod of 5 is 2. Since the highest multiple of 5 that can be subtracted from 12 is 10. Therefore, 12 minus 10 is 2. Therefore, the remainder for the given problem is 2. Hope you have understood it. Next question, that is third question. For 10 raised to 32, if it is not visible, then here I will write it once again. 10 raised to 32 to remainder of 11. We need to find when the number 10 raised to 32 plus 2 is divided by 11. This is assuming the question to be. If you think it's the other way around. Now we need 10. We will simplify it by step. First, we will consider only this part. 10 raised to 30. 10 raised is short. 10 is divisible. What number should be added to 10 so that it is divisible by 11? Minus 1 should be added, and 1 should be added. That is written as minus 1 mod of 11. Now rising, we need 10 raised to 32, but we have 10. Raising to the power 32 on the both the sides, we get at 10 raised to 32 is congruent to minus 1 whole raised to 32 mod of 11. Okay. Now minus 1 raised to even power is always 1. Considering that, we will write 10 raised to 32 is congruent to 1 mod of 11. Now adding both, we need 10 raised to 32 plus 2. Adding both sides by 2. Adding both sides 2, we get it as 10 raised to 32 plus 2. 1 plus 2 is mod of 11. 1 plus 2 is 3. 3 is less than 11. Therefore, the remainder is 3. Fourth question. If you evaluate 999, that is 69 square plus 498 squares, that is 498 square, when it is divided by 99999, what would be the remainder? We know that this term is completely divisible by 999 since it's a multiple of it given number. Therefore, this number is one short of, it is one short. So that when you add the 1 to this number, then it will be divisible by the given 5 nines. Now we need 99998 square should be divisible by squaring on the raising to the power on the both the sides. We get it as minus 1 whole raised to 2 mod of 99999. Now after simplification, we get it as 1 minus 1 raised to 2 is 1. and adding we need adding these two, this one and this one, we get it as 0 plus 1 as mod of remainder is 1. Now fifth question, what is the remainder when 8 raised to 100 plus 9 raised to 100 is divided by 7? We know that what number should be subtracted from 8 so that it is divisible by 7, or a remainder, what is the remainder when 8 is divided by 7? We get it as 1. Okay, now we need 8 raised to 100, but we have only 8. Raising to the power of 100 to the on the both the sides, we get 8 raised to 100 is congruent to 1 raised to 100 mod of 7. Therefore the remainder is 1. This is the first part. Now we will look at the second term. We know that 7 multiples are 7, 14, 21, 28. Now we have 9 cube. Something is wrong, sorry for this. Just a minute. First of all, we will write 9 raised to 100 as 3 raised to 200. Okay, after writing this, now we will check on the multiples of 9. Okay, now we will go on checking the multiples of 9, that we will the remainder, please do it by yourself. The remainder will be 2 for this term. Then when we add these two terms, we get it as 8 raised to 100 plus 9 raised to 100. When divided by 7, the remainder will be 3. Hope you have understood it. If you have any doubts, you can comment below. I will help you out. Question number 6 says that what is the remainder of 2 raised to 256 when divided by 17? Okay. What is the now we have 2 raised to 4, 2 raised to 0 as 1, 2 raised to 1 as 2, 2 raised to 3, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16. What number? This is nearer to 17, right? Now what number should be added to 16 so that it is divisible by 17? 1 should be added so that it should be divisible by 17. We write it as minus 1. Okay. Now we need 2 raised to 256, but we have only 2 raised to 2 raised to 4. Now raising to the power 64 on the both the sides, we get it as 2 raised to 4 whole raised to 64 is equals congruent to minus 1 raised to 64 mod of 17. Now, or we can use the direct property, or else this can be used by using the Wilson's, or I think so Wilson's, or okay, I will discuss this in the next videos about the special type of problems. Now we will solve in the general method. Now 2 raised to 256 is congruent to 1 mod of 17. Therefore the remainder when 2 raised to 256 is divided by 17 is 1. Hope you have understood it. Now let's move on to the next question. Question number 7 says that what is the remainder when 2 raised to 2015 is divided by 17? Mostly this is a question from the year 2015 exam. Here we go. 17, again the same as discussed in the 6th problem. It is 2 raised to 4, now 1 plus 7 is divisible by 17. Okay, this will be divisible, therefore we write it as minus 1. Now we need 2 raised to 15, but we have only 2 raised to 4. Now rising to the power 503 on the both the sides, we get it as minus 1 whole raised to 503 mod of 17. Minus 1 whole raised to odd number is minus 1. Okay, now keep it as it is. Don't convert it to positive number by adding 17. It will make more difficult to simplify. Now 2 raised to 2012, what we need 2015, but 2015 we have 2012. Now multiplying both sides by 2 raised to 3, we get it as minus 1 into 2 raised to 3 mod of 17. That is minus 8 mod of 17. Now we can convert it to back positive remainder, that is 17 should be added to minus 8. We get it as 9. Therefore the remainder when 2 raised to 2015 is divided by 17 is 9. Eighth question. How do I find the remainder when 4 raised to 666 662 divided by 17. Now as earlier discussed, 17 multiples, we go on writing the 17 multiples. 17, 14, 21, 28, 35, 42, 49, 49. After 49, what you will get? 56. Then we get it 56 plus we have the multiple of 7 nines as 63, but we have 4 cube as 64. What number should be subtracted from 64 so that it is divisible by 7? It is -1. We write it as 1 mod of 7. Okay. We need 4 raised to 662, but we have 4 cube. Now rising to the power on the both the sides to 220. How we find it is by dividing 662 divided by 3. After that we get it as 2 to 0. Okay. Point some x, y, z. Don't think about this. Just you need to find the quotient. Now rising to the power 222 on the both sides, we get it as 4 raised to 660 is congruent to 1 mod of 7. Okay. Now we need 662. Now multiplying 16 on the both sides, that is 4 square on the both the sides, we get it as 16 mod of 7. Now 4 raised to 662, it should be, sorry, it's okay, correct. Now subtracting the 16 divided by 7, what is the remainder? 14 multiple, 7 multiple, that is 14 will go from, we are left with only 2. Therefore the remainder is 2. Hope you have understood this. Now let's move on to the last two problems. Question number 9 says that what is the remainder when 17 raised to 1000 is divided by 7? Okay. That is, now we will we know that when a raised to p minus 1 is congruent to 1 mod of p. P is a prime number. P is a prime number. Here 7 is a prime number. Therefore we can write it as a raised to 6 is congruent to 1 mod of 7. Here the value a of a is 17. Now raising to the power on the both sides by 1, that is 1000 divided by 6, you get it as 116. 116, no, it's not 116, it is 166. Now rising to the power 166 on the both sides, we get it as 1, and now we need 1000. Therefore we will add 17, that is multiplying 17 raised to 4 on the both the sides. After simplification, there is same procedure. After simplification, or you can multiply and check it out, and after simplification you get it is the remainder as 4. Hope you have understood this question. If you have any doubts, you can comment. I will come for your help and I will solve your problem. Now last question of this video. What is the remainder of 2001 raised to 99? That is 2001 raised 2001 raised to 99 divided by 7. Okay. Now we all know that 2001 square can be easily found out, and it is perfectly divisible when 1 is subtracted from that number. Therefore the remainder is 1. Now raising to the power 49, that is we can find it as by that is 999 divided by 2, we get it as 49. Okay. Now rising to the power 49 on the both the sides, we get it as 1 raised to 49 mod of 77. Now we get it as 2001 raised to 98 is equals to congruent to 1 mod of 77. We need 2001 raised to 99. Therefore multiplying by 2001 on the both the sides, and after that you need you can do normal division. You can find it the remainder to be 76. Therefore the remainder when 2001 raised to 99 divided by 7 is the remainder is 76. Therefore the answer is 76. Thank you for watching this video. Stay updated for more lessons. Thank you. Please do subscribe to our channel so that more and more lessons and courses will be added soon. Thank you.